Let's just jump right in. Welcome to this explainer. Today, we're popping the hood on what I honestly think is one of the most fascinating materials science breakthroughs of our time, and that is seaweed plastic. We're going to break down exactly how this works, why it matters, and how it could completely change the way we package our entire world. Okay, so take a second and just picture this. You're having a great day at the beach, you finish up a bottle of water, and instead of frantically searching for a recycling bin or, worrying about that plastic ending up in a landfill forever, you just toss the bottle right into the ocean. I know, right? It sounds incredibly wrong based on literally everything we've been taught. But imagine if, by tomorrow morning, that very same bottle had completely dissolved and turned into healthy, nutritious fish food. It sounds like straight-up science fiction, but the crazy thing is, it's rapidly becoming science fact. So, to really understand how this works, we need to go under the hood. Like, how exactly do we take a slimy plant from the sea and transform it into that clear, crisp material that wraps the sandwich in your lunchbox? It is a brilliant piece of science. But before we can fully appreciate the solution, we kind of have to clearly understand the problem we're actually trying to solve here. Which brings us to Section 1, the plastic problem. Regular plastic, as you probably know, is manufactured primarily from oil. But the real issue is how it's built at a microscopic level. Think back to playing the game Red Rover on the playground when you were a kid. Well, in regular oil-based plastic, the molecules are essentially playing the most intense game of Red Rover ever conceived. They link up and they hold hands so incredibly tightly that absolutely nothing can break through their line. Out in nature, bacteria and microorganisms act as the recyclers, right? But when they encounter regular plastic, they just bounce right off. They literally cannot break those chemical hands apart to digest the material. And because those molecular bonds are so ridiculously stubborn and refuse to let go, we get to this staggering number, 500. A single everyday plastic juice bottle can stick around in our environment for up to 500 years. Just think about that for a second. A drink that takes you, 5 minutes to consume leaves behind a ghost that haunts the planet for half a millennium. That is a massively long time for one single piece of trash to stick around, clogging up our waterways and harming wildlife. Let's move on to Section 2, the seaweed secret. The solution to our 500-year problem has literally been floating in the ocean all along, just hiding in plain sight inside everyday seaweed. The absolute crucial ingredient making this possible is called alginate. If you've ever actually touched seaweed at the beach, you know it feels kind of unique, right? It's stretchy, it's flexible, but it's remarkably strong. Strong enough to survive getting battered by ocean waves all day long. That strength and flexibility, that comes directly from alginate. And scientists have figured out how to extract that alginate and mix it with just a little bit of water and some natural minerals. When we put these materials side by side, the chemical difference is absolutely staggering. Regular plastic is engineered like an unbreakable steel chain. It is completely rigid on a chemical level. Seaweed plastic, on the other hand, is cleverly engineered more like a sugar chain. It still gives you all those practical benefits you want. It's easily strong enough to hold your sandwich, keep your food fresh, survive being tossed around in a backpack all day. But chemically, it has a built-in self-destruct sequence. The breakdown process is incredibly rapid. Step 1, the seaweed plastic hits the ocean. Step 2 is where the actual magic happens. The ocean's natural combination of salt and water acts exactly like a key fitting into a lock. It instantly unlocks that sugar chain. And step 3, instead of breaking down into those awful, harmful microplastics, it completely dissolves and becomes natural nutrients. It literally feeds the ecosystem. And that leads us to Section 3, the future of engineering. So why does this scientific breakthrough matter so much? Because it is a fundamental shift in how we manufacture our world. Seaweed plastic essentially acts as nature's recycling program. Since it's made entirely from plants, it doesn't just disappear into a landfill somewhere. It actively gives back. When our traditional human recycling fails, nature's recycling program steps right in. The material simply returns to the earth as food. It completes a perfect, harmless circle. The real-world impact of this is massive. Think of every single plastic straw, every candy wrapper, every single-use bag you interact with on a daily basis. If we utilized this seaweed secret for all of those items, we would have drastically cleaner oceans almost overnight. And our sea turtles, our fish, and our birds would be so much safer. They would no longer mistake 500-year-old steel chains of plastic for their next meal. Ultimately, this represents the true, bright future of engineering. The goal isn't to stop inventing things or to stop using convenient things. Not at all. The goal is to build things that help us today without hurting the world tomorrow. It's about finally working with nature's chemistry rather than constantly fighting against it. Which leaves us with this final thought for today. We've just seen how scientists looked at a slimy, everyday ocean plant and saw a global solution to one of our absolute biggest pollution crises. It proves that the answer's out there, they're just waiting in nature. So, if a slimy sea plant can be engineered to replace plastic, what incredible world-changing solutions will you engineer tomorrow? Keep observing, keep questioning, and definitely keep learning. Thank you so much for joining me on this explainer, and I'll catch you next time.